So, we don't have class on Friday, so the next time we meet after today will be next Tuesday. So, this is a chance for you after today to make sure that you are up to date with Chapter 2 and Chapter 1 if you're still working on that. Today is relatively light, I think. It's not too heavy. Heavy stuff is coming next week with linear regression. So all the stuff that I'm presenting today, we covered in year 11 last year, if you were in the class. You might have forgotten it, so we'll go over it again. So let me begin by just reminding you of the picture that we have drawn multiple times so far. You don't have to copy this down. The stuff to copy down is on the next slide. So this could be an experiment, this could be a business, but you're collecting data where both variables are numerical. So each cross is a data point. And the question that we're going to be asking for pretty much the rest of the term is there a relationship or is there an association between the x and y variables? The reason why this is important is because let's imagine this was the price. I don't know if any of you invest money, but you will someday, probably. If this is the price of a share, so you know what a share is? You own part of a company, and then they give you some of the profits. Yes, you would. So, if this is the price of your shares over time, that looks all right. It's going up, right? You're going to make money. But if it's going down, not so good. You're losing money. So, one of the things that we'll learn to do at the very end is this will be data over time, and we'll be able to predict what happens in the future. Okay? But in order to do that, we need to understand whether there is some sort of association or relationship between x and y. And we're going to spend a lot of time doing this, fitting a straight line. That's coming next week. Okay. So if you lose track of where we're going over the next few weeks, always keep this picture in mind. We've got numerical data, and we're trying to decide whether there's an association or a relationship between the two variables. All right. So the big idea here is, because I know people like questions, what kind of is there an association? That's the question we're asking here. So I would like you to get this down, especially if you weren't in my class last year. Of course. I can put it up straight away. Alright, so I'm going to give you the theory and then we'll do some examples. Okay. Because we started late, let's try to write one forward. Okay, please pay careful attention to this section because you are very likely to get an exam question on this. I've already written half the stack and I put a question about this on the stack. To do this. So I'm going to give you some numerical data, a scatter plot, and I will ask you to describe the association between the two variables in terms of three things: the strength, the direction, and the form. You will need to comment on all three things. Um, and you'll probably do it on the exam as well. Yes, Caitlin.
And it won't be like laid out like that every sauce here just to
So, let me define these terms and then we'll practice it in a moment. So, form. Form has two types. There's linear and non-linear. Do you know what linear means? Straight line, okay? So, if it's linear, the data tends to follow a straight line. Now, I think I need to give you some examples. So, if you would have a look at the third one in the lower left-hand corner here, you can see that it's not exactly a straight line. So let's have a look up here, guys. So you see this one here? It's not a perfect straight line, is it, right? But we would still call it linear. This one, it's not really a straight line. As we'll see in a moment, it's kind of around the straight line. So if you tend to see something like this or this, you would still call the association linear. It's only when you have something like this. See how it's curving? That one's clearly, that's one that's not linear. Okay. Okay, I'm just going to write not linear because I'm lazy. Okay. All right, we okay with linear? Linear, you're looking for a straight line. Second part, direction. So positive means when x or your EV increases, y, your response variable, tends to increase. So let me give you a couple of examples. In here, so the data is not on a straight line, but it's approximately on a straight line. And what I'm noticing is as I go in this direction, the y values tend to go up. This will be an example where the direction is positive. Okay? The opposite, as you might guess, is this. As x increases, y tends to go down instead of up. So in this case, it would say the direction is negative. Is that all right? So y is increasing when the direction is positive. Y is decreasing when the direction is negative. So I'll label this positive direction, negative direction. All right, you guys okay? Yeah. All right. The last one, this can be a bit subjective. So next period, after we complete 2E, I will make this precise. We will calculate a statistic called R, the correlation coefficient, which sounds quite familiar if you did it last year. And we'll classify the strength of an association based on that value. But at this stage, we don't know what that is. And sometimes, unfortunately, in the exam, they don't give you the data which allows you to calculate R, which means that you have to make a judgment on how strong the association is. So I'm just going to give it to you. This is quite subjective, which is why I'm not going to spend a lot of time on it, but there is a stage in this course where, yeah, they'll give you a plot, they won't give you R, and you'll have to make a decision. Broadly clustered and loosely clustered. And I'll just write a note here. Later we will use R. Or note, most of the time we will use R. On the SAC, you will use R. I will not leave it to a subjective judgment. Okay, so this is all theoretical. Let's get practical now. Let's apply these 3 steps to 4 examples, which are given in your textbook. Okay, so this is question 2 from exercise 2E. Don't you just love it when you can tick off the work program during class? Okay, so remember, there are 3 things we are looking for. Strength, just strong, moderate, or weak. Direction, which is either positive or negative. And form, which is either linear or nonlinear. Those are the words you need to know. And let's now see if we can apply these to the 4 scatter plots. All right, I think number 3 is the easiest one, so let's start here. What do we reckon the form is? Form is linear. Okay, I'll make it clear. Part 3, form, linear. Direction, positive. And strength, strong. So if I draw a straight line, it's very easy for me to draw a straight line around which the data is tightly clustered. So this is probably the most straightforward one. It's strong. Okay, so that's good. Ooh. Now I can't rub that up. So the eraser erases everything, not just the yeah. All right, let's do part 1 now. Okay. Let's start with direction. Yep. Because on average, when x goes up, y goes up. Form. Yeah, so I think it's linear. So I should also say it's all a little bit airy-fairy right now. Later, we will use something called the residual plot. And for strength, we will use R later. So this stuff in orange is stuff that's going to come later in the course that will make this much less subjective. Yes. Yes, you can. Okay, and strength.
Moderate?
Yeah, so can you see how like these 3 labels, there's some overlap at some point, right? So I think moderate is the way to go here. It's not as tight as this example, but it's the points aren't like super far away from the line either. So that's why I would agree with moderate. As you can see, this is subjective. When we calculate R, it won't be subjective anymore. But annoyingly for you, you can still be asked to do this in a subjective manner. So, but I do think that the questions won't be they won't be out to get you with this kind of question. Okay, number 2. I think direction's the easiest one.
Negative.
So why is it negative this time?
Because X is Y.
Decreasing. When X increases, on average, Y decreases. Okay, form. So this one's interesting. It's hard to tell. I have a suspicion this one is still linear. I don't see a very clear curvature in the points, but it could be nonlinear. I haven't looked at the answers for this because I wanted to have the discussion with you, but you can look it up. Okay. And strength. Yeah. I think weak is the way to go here. It's not as tight as this, is it, right? So I think I will go with weak as well. All right, and last one, number 4. Whoa, what's going on? I don't know what this is. Yes, and it's a no from me. Okay, sorry guys. Last one. Yeah, I actually don't know with this one. Nonlinear? I think that's fair. So let's see. So guys, listen up. So, okay, now we can debate the back of the book, by the way. The back of the book is not God. Um, but the suggestion that the textbook authors have is that this scatter plot is nonlinear. Um, I'm happy to go with that, but we need a reason. So, what would be your reason for saying this is nonlinear apart from the back of the book?
Put like a line through it, like just straight far. Yeah, but you can still put a straight line through that. It's just going to be literally a straight line horizontally. So you can argue to do that when X
Yeah. Okay, so I'm happy with that. I'm actually seeing 2 effects here. I'm seeing this. The points here are tightly clustered, and these points are not so tightly clustered. So what I'm saying is, for your data to, you need some sort of consistency. If you have these two group things happening, like the physics students will know this. Like this is not something. This suggests that you have 2 effects in your data, which you haven't separated.
and you just look at every single dot and put it in every position, and then find R, and then you use R.
Well, you can't. Well, you can't do that because you need all the points to calculate R.
Exactly. So you figure out what each point is. Like the first one is 20, maybe.
Yep.
1 or 5.
So so Jason, that's actually a good idea. Except that I don't want to read all the points into the calculator.
That's just me.
Yeah, and I am lazy. I accept the charge of being lazy.
Most mathematicians are lazy.
We want to be efficient, you see. Sorry, form is nonlinear. Direction.
suppose it's pretty much
It's not much here, right?
It only goes back to the books because this is like no association.
Yeah.
I mean, it really just depends on the strength, because if it's higher than 0, it's going to be positive. If it's lower than 0, it's going to be negative.
Maybe it's just 0.
And I'm guessing, did they say none for strength as well?
Yeah.
Yeah.
So that would be between negative 0.
So I guess I should have said that there's another option. I'll put it in. You won't be asked to classify none, but you can have no strength and no direction. So your strength is none when there's no pattern, and your direction can be none when there's no pattern. Yeah. But we're not real. That's not the focus of this course. I guess because, like, for example, R can be, I don't want to repeal the R, but like, you could ask, is there an association between random data, like completely random data? The answer is no, right? But none of these labels, strong, moderate, or weak, fit with completely random data. See? So I've tried to focus on the things that are important, and when you do that, you have to leave out some technicalities. Okay, who didn't like this? So I don't like this because it's too subjective. I can't look at a picture and say, is that weak or is this moderate? Because you've got a scale that's different as well. So if I scale this differently, the point will look further or nearer to the line. What I want, which is coming soon, is a more precise way to decide whether the strength is strong, moderate, or weak, and whether the form is linear or non-linear. Because right now, I'm kind of just using intuition looking at the graph. And intuition is not repeatable across different people. We will all have different judgments. Yes, Tim?
Is that just when we find R?
Exactly.
Yeah.
So here I said we'll use R, and here I said we'll use the residual plot. So we used R last year. We didn't do the residual plot last year. That's new for this year. Okay, so what I'm going to do now is I'm going to give you about 10 minutes just to do question 1 from 2E, and 2E is done. Because there's only 2 questions there. So I'll give you 10 minutes to do question 1 from 2E, and then we'll do 2 classes together as well. Did we do 2D last lesson? I should have described one. Yeah. So 2D is just maybe snapshots. Half the questions I just put this into the calculator.